All right, so solving exponential equations we've gotten on our radar. Now we're going to go through solving some logarithmic equations. So what is a logarithmic equation? We went through the definition of exponential equation. Logarithmic equation, let's see the definition here. Logarithmic equation, an equation containing a variable in a logarithmic expression. So the difference being before our variable was contained in the exponent, now it's contained inside this logarithm. So here's our variable inside the logarithmic expression. So how are we going to solve this? Kind of similar, I guess, but opposite of the method I showed you guys towards the end of the explanation of exponential equations. The opposite, so these are logarithms instead of exponentials. Some things are still similar. You want to isolate the expression. So before was the exponential expression. Now you want to isolate the log expression. So there shouldn't be a 5 times log base 5 of 3x plus 1. You want to isolate it, get the log portion all by itself. The second step, so opposite of, again, what I was telling you about exponential, you're going to write this expression, write the equation in exponential form. So we'll look at what that looks like in an example in a second. But so get that logarithm part alone, then you're going to write it as an exponent. And step 3, from there it should be pretty obvious how to solve. We just solve, get x alone. So the example we just saw, step 1, get the logarithm alone. So you want to make sure there's nothing outside of this logarithm. It's all alone on this side. So step 1 was already done for us. Step 1 to get the log alone. Step 2 is write this in exponential form. So you want to think base power equals a number. And if you remember, our logs are always equal to, this is our power. The base on your log is also the base on your exponent. So 5 to the second equals, and this is 3x plus 1. So we want to switch our our logarithmic equation into an exponential. So 5, and you can almost think of it as like this arrow formation going counterclockwise. 5 to the second equals 3x plus 1. So 5 to the second is 25. And now we solve for x like we normally would. Subtract 1 from both sides. 24 equals 3x. Divide by 3, so x equals 8. So fairly simple process. There's not much to complicate it. The only thing, so circle our answer there, the only thing that may come up that throws a wrench, I guess, into the plans is what if the logarithmic expression is not by itself. So you need to think, I'm isolating just the log. Anything else that's included shouldn't be in that particular problem. So how do we isolate the log here? We're going to subtract that 5, and you're left with negative log base 4 of 2x equals 3 minus 5 is negative 2. And then we want, again, you don't want negative log, you want the log all by itself. So we need to divide by negative 1 to get the log all by itself. Log base 4 of 2x equals positive 2. So take a second here, write that in exponential form. So we've got the log alone, write it in exponential form, and then check your answer. So as and as an exponential form, it's 4 is the base, 2 is the power, 2x is what it's equal to. So 4 to the second equals 2x, 16 equals 2x, divide by 2, so x is equal to 8. Again, different problem, different steps, same answer. So make sure tomorrow you're prepared to show your work as well as what the answer actually is. Solving logarithmic problems, solving exponential problems, kind of the opposite methods. To solve a log, you use an exponent. To solve an exponent, you use a log.